to the Math Cafe, enough pie for two. I am Miss F.
And I'm Mrs. H. Hey, where's the pie?
Oh, the pie. We gotta work for the pie, I think, in this one.
What? No pie?
Yeah, not today.
That's disappointing.
But today, instead, we will be learning about circle geometry, and in particular, the tangent radius property.
That sounds like fun. So for today, you guys are going to need the worksheet supplied, a protractor, a ruler, and a pencil. Make sure you have those supplies handy.
And at any time in these videos, if you feel like you need to, just pause or start from the point that you need to look at again. You have that ability.
Wait a minute, they can mute us?
Yeah, kind of scary.
They can pause us? Good thing you don't have that ability in class.
Make sure you don't mute us too much, though. You still need to learn.
All right, I guess let's get started.
Awesome. First, use the circle on your handout, and on the circumference mark 5 points, A, B, C, D, and E in order.
Okay, so you're going to make 5 points on the circle. Point A, B, C, D, and E, like so.
Now let's join the points A to B.
Okay, so we're going to start joining points here. Alright, so a line from A to B,
A to C,
A to C,
A to D,
A to D,
E to B,
so from point E back to B,
E to C,
E to C,
and E to D.
E to D. Okay, like so?
Perfect. Now we're going to use your protractor to measure and record the following angles.
Okay, so what's the first angle we're going to be doing?
Angle ABE.
Angle A, B, E. Alright, so we're measuring the angle A, B, E. So the angle formed here. Alright, so let's pull up my protractor. I do have to rotate it. Alright. And this is a little hard to measure, so it looks to be the angle formed is about, oh, it's tough to say there, about 80 degrees. So I've got an 80-degree angle there.
Record this on your handout.
Okay,
Now we're going to measure angle ACE.
so from A to C to E,
So the angle at C there.
A, C, E. Okay, I'll take the protractor out again. Oops, kept it the same way there. Alright, and it's looking to be about 80 degrees again.
Nice.
80 degrees. Okay, and what's next?
Lastly, let's measure angle ADE.
So from A, D, E, the angle formed here. Alright. And once again, it looks to be 80 degrees. Just move this out of the way. Okay, and
Now that we're starting to see a pattern, let's go to another circle on your handout and see if we see this happening again.
okay. All right, Mrs. F, let's try this one last time. Okay, everyone, take out the last circle on your handout, and once again, label points A, B, C, D, and E in order, but in different positions this time than your previous circle.
So A, B, C, D, and E, entirely different positions.
Perfect. Now we're going to draw some line segments again. Join point A to point B, point A to point C, point A to point D, and now draw in line segments from point E to B, point E to point C, point E to point D. Perfect, Mrs. F. All right, now we're going to use our protractor and measure the angles. The first angle we want to measure is the angle formed from point A, B, E.
Okay, so get out your protractors and we'll measure point A, B, E.
Perfect.
Okay, so mine looks like it is about 45 degrees. So we'll just write that down. So angle ABE is equal to 45 degrees. And of course yours will be different than mine, depending on how you do your points.
All right. Next, I'd like you to measure the angle formed from points A, C, E.
A, C, E. So remember that we're going from A to C to E. So we're measuring angle C here. And that looks to be about 45 degrees again. So angle A, C, E is equal to 45 degrees again.
Okay, perfect. And now the last angle you're going to measure is the angle formed from points A, D, E.
All right, entirely different spot here. Let's go to angle ADE. Flip it around. All right, and again, we're looking at 45 degrees. So angle ADE is equal to 45 degrees.
Okay, let's put it all together now.
Okay.
Okay, Mrs. F, let's put it all together now. So let's take a look at the first example. All right, so taking a look at the angles we drew, angle ABE, ACE, and angle ADE, what can we say about them? So first of all, we know that they're all inscribed angles, right?
Yep.
Because they're formed by, every angle here is formed by 3 points that are on the circumference of the circle. And another thing we notice about the relationship between these 3 inscribed angles is that if you follow along, they all have something in common. What is that, Mrs. F?
They actually involve the same arc from A to E.
Absolutely. They're all sharing this one common arc, right? So if you take a look, ABE has this arc, ACE has this arc, ADE has this arc. Excellent. What else do we notice about the angles formed by all 3 of these inscribed angles?
Well,
Look.
every time we measured the angles in angle B, angle C, and angle D, we saw that they were 80 degrees.
Perfect. Now let's look at the example that you did. All right.
All right, so when we did the same here and we had angle ABE, angle ACE, and angle ADE, these are also all inscribed angles because they each share 3 points on the circumference of the circle, as well as the arc from ABE is here, ACE is also here, and ADE, you can see it, again, it uses the same arc.
So it's got 3 inscribed angles that all share the same arc. What else?
And so when we measured them again, we saw again that they were all the same measure for 45 degrees.
All right, so let's put it all together. I guess we could probably say that if we have inscribed angles that share a common arc, the measure of their angles are always going to be equal.
Equal.
Right. Why don't we look at a practice question and put this all together?
Awesome.
Good.
Pause.
Pause. Nice.
Okay.
Take 9,564. Okay, so when we're ready? We're good? Okay. Okay. All right, Mrs. F, let's take a look at practice question 1.
All right, so if you take out practice question 1, let's look at the information that we're already given, because math, again, is about what you do know and not what about you don't know. So let's read about what we do know. And that point O is the center of the circle. So we're told here that this angle here is the center of the circle, so we know that this is a central angle. So let's already write what we know. So angle O is equal to 120 degrees. And that is the center of our circle, so that is our central angle. If we also trace along from the same points, from here to here, up to X, So if we follow along up here, and then around on our arc, and then back through to our central angle, notice that these two angles share the same arc on the circle from these 2 points. And that tells us that we have our central and inscribed angle property that we can use here. And that means that our central angle is twice our inscribed angle, or our inscribed angle is half of our central angle. So if we take half of our center angle, we know that angle X is equal to 60 degrees. From here, we need to solve for Y now. All right, so we know again that if we take our pen and follow another one, notice that Y is also an inscribed angle, so maybe it's possible that we could use our inscribed angle property here. All right, let's look at X. So if we trace to X, back down to this point and around, we can also do the same going up to Y, back down, and around the same arc again. So inscribed angles that share the same arc also share the same angle. So we know that the angles are equal, so X, angle X, is equal to angle Y. So that means that angle Y is equal to 60 degrees. And we have solved for both angle X and angle Y. Okay, Mrs. H, let's look at practice question number 2.
Okay, so turn to practice question 2, and let's take a look about the information that they're telling us here. All right, this looks like a lot of angles to solve, but if we apply our properties, it's not going to be that difficult here. So let's see. The question tells us that point O is the center of the circle. All right, so I'm going to try to use our central and inscribed properties to solve for angles W, X, Y, and Z. All right, they're also telling us in the question that this angle here, all right, so the angle here is 60 degrees. All right, all of the information that I need to solve for the 4 angles are here. The first thing I'm going to do is I'm going to look for a semicircle here, and in fact we have one. The central angle formed here, all right, from B, O to D, all right, I have a semicircle here, right? So it's a straight angle. I know that is 180 degrees. I'm going to put that information in the circle. All right, so there's my central angle, right? The angle formed here, and here's the arc, all right, that it uses. I'm going to look for an inscribed angle that shares the same arc, and in fact we have one. If you take a look here, right, starting from D to A to B and then back around, all right, that's an inscribed angle that shares the same arc as this central angle. So now I can apply the inscribed and central angle property. This central angle, if it measures 180 degrees, I know that this angle here, the inscribed angle, would be half of that. They're also telling us that this part of the angle is 60 degrees. So half of 180 degrees, that would be 90 degrees, but because this part of the circle is 60, if I take 60 and subtract it from 90 degrees, that will tell me what angle Y is. All right, so if I know that this is a 90-degree angle, because it's half of 180, take away the 60, that means angle Y has to be equal to 30 degrees. All right, so now I've solved angle Y. I'm going to take a look at what other information I have in this question. I always look for triangles in circle properties questions because often you can find an isosceles triangle, and we know something important about isosceles triangles. So let's take a look here. This triangle, maybe I should use a different color here. All right, so the triangle formed here, all right, these 2 side lengths of this triangle I know are equal, and the reason I know that is because they both start at the center and go out to the circumference. So I know that the length here is equal to the length here because they're both radius, right? They're both a radius. Therefore, I can apply the isosceles triangle property to this. I know that the 2 angles here that are opposite those equal lengths are going to be equal. Therefore, if angle Y I've just figured out is 30 degrees, I know that angle Z also has to be 30 degrees. All right? So we're putting it all together here. Alright, I still have angle W and angle X to solve for. Angle X actually isn't too difficult now. Now I can apply the theory that are the property of a triangle, knowing that all three angles add up to 180 degrees. So take a look what we have here. A 30-degree angle, a 30-degree angle. Now I can solve for this angle here by taking 180 degrees and subtracting 30 twice. All right, which means I'm taking 60 away from it. That leaves me 120 degrees. All right, so I know that this angle here is 120 degrees. All right, how does that help me solve angle X? Well, if I follow the line from B to D, right, that's the diameter of the circle, it's a straight line. And we know that straight lines, those are called straight angles, they form an angle of 180 degrees. If this is 120 degrees, what's left over? Well, I have to subtract 120 from 180 to solve for angle X. All right, so we can do that. I'm hoping most of you guys can do that in your head. So 180 degrees, take away 120 degrees, left over is 60. So that's telling me now that angle X is a 60-degree angle. Alright, so we've solved angle Y, angle X, and angle Z. Now to solve for angle W, I'm going to have you do something with your paper. Okay, so now what I'm going to have you do to solve for angle W is I want you to take your paper and turn the question around, like I'm doing. Watch. A lot of times, it's really important to look at the question from different angles, and you'll see why in this example here. If you take a look at the angles formed here, so from A to B, all right, to D, that's an inscribed angle, and we just figured out that Z had an angle of 30 degrees. All right, and we just solved that previously. If you take a look, angle W from A to C to D, both of these inscribed angles share a common arc, and that's the arc, whoops, that's the arc here. And we just learned that inscribed angles that share a common arc, the measure of those angles are equal. Therefore, if angle Z is 30 degrees, we know that angle W must also be 30 degrees. So using our what we know, the properties about central and inscribed angles, we've just solved this question that looked pretty difficult, but in reality wasn't too hard. Nice work.
Those teachers sure do a great job.
Yeah, that was us again.
Oh yeah, right.
Weird. All right.
Let's wrap it up then today and summarize what we found out.
All right, so we were looking at inscribed angles today, and we found out that inscribed angles that share the same arc, the measure of their angles are equal.
Oh, that's about it, I guess. I guess that sums up our circle geometry unit.
No, wait a minute. Where's my surprise?
Oh, right, your pie.
That's right. Thought we were gonna eat some pie here.
There you go. I brought you some pie.
So lame.
Fair enough.
Man. You
That
are
is
a math
pretty
teacher.
lame.
All
I
right.
actually bought you some real pie. Okay.
That's my pie. Now it is. Alright. Okay, so you're introducing, right?
So welcome back to our last episode of Math Cafe, Enough Pie for Two.
Well, last episode for circle geometry anyway.
Oh yeah, that's right.
There might be more. Alright, so what are we talking about? Oh, no, we need pie.
Okay, you forget.
Start again.
I'll say if you're lucky, and then you'll say, "Oh, hey, today's pie" or something.
We
When
get
you
pie
like
today.
remember. Okay. So, okay. Welcome back to our last episode of Math Cafe. Enough pie for two.
Well, last episode for circle geometry anyway.
Right. If you're lucky.
Hey, last episode. Does that mean we get some pie today?
I don't know why I said if you're lucky. That made no sense.
Yeah.
You have to say we might have more.
Okay.
Right? Because you were saying that
Maybe
before.
there'll be more.
Yeah.
Okay, sorry.
Whatever. Otherwise, I'm not going to say it.
Okay. Pause. That's complicated, eh? Look at how messy it is.
It's actually not bad.
No? Okay.
No. No, because you're drawing those lines out. I think it looks good.
Okay.
If you had tried to do the last one on there, well, I'm nervous to use the smartboard, and then I'm nervous that I'm taping.
Alright. The last part of this. Oh my god! Okay, oh wait a second. So what do we...
I'm saying,
Here, let's wrap.
look at those teachers. Those teachers
Oh
did
yeah,
a great job.
that was us.
Okay.
Oh yeah.
Okay.
And then you say, let's wrap it up. I talk about what we learned.
Mm-hmm.
And then you say, that's it. And I say, wait a minute, where's my surprise?
Yeah.
Alright.
Go.
Alright.
Right. Can I start now?
Yeah, you can start.
All right. Those teachers sure do a great job.
Yeah, that was us again.
Oh yeah.
Great. Okay. So let's wrap it up.
Is that what I was supposed
Yeah,
to say?
you gotta do it
Okay,
again.
this is- okay. I always forget my line.
You say wrap it up, I wrap it
Too
up.
much caffeine at lunch.
Try it again.
Getting crazy up in here. All right. All right. So those creatures. Why do we always get the giggles?
Was that creatures or creepy teachers? Alright, go on.
Depending what kind of pie.
Go on. Don't make me start laughing.
Okay.
Wait a second, hold on. It's because you're in here now.
And after lunch we get giggly.
Mhm.
Yeah, that happened last week too. Okay.